The next question is from Jan 2019 and paper 2. This is a chapter-wise sequence. So we're doing the next question is from number 8. This question is about moment. So the moment it's about moment, we know that we will need some information about what is the moment, what is the principle of moment, and the calculation of moment is important. So here, if you read the question at your own time, you will see that the diagram is given and they're asking us what is this 18 Newton force. So name of the force. So if we look at here, this is this. Another important information in this part was this uniform word. Uniform basically means that the center of gravity where the whole weight acts is basically at the midpoint. So if you have a rod that is 6 meter long, so you will have the center of gravity at 3 meters. Here the whole rod is 8 meters, so your center of gravity is 4. That's why they haven't told you about the distance. They expect you to understand this. So first they are just asking us the name of force. We will just say it is the weight of the crane arm. Weight of crane arm, which is this one. The crane arm is this one. So next question asks you directly moment. Just write down the formula, get it from the formula book and write it down. Next question, calculate the clockwise moment and of the weight of the counterweight about the pivot. So he's asking you to find the counterweights. So counterweight is here. We know it's straightforward. This is the distance. The distance is always calculated from the pivot. So here you're lucky it's given 1.2. So you can straightforward say it's 150, 3 more zeros into 1.2. This is moment. Just to get more information, write clockwise moment. So you know that this is clockwise moment. And this is equal to 180,000 Newton meter. Excuse me. The next question here it says that calculate the weight of the rock. So we are trying to find the weight of the rock, which is this one here. So they have labeled this force as W. We will also use it F. The label the force F. We will use the letter F here. Now, few distances needs to be found before we proceed forward. So we already know here we have a clockwise moment, which is equal to what you have found just below. There are some anti-clockwise moments, which is this one due to this force, and this another one because of this one. So let's say we say anti-clockwise moment 1, and this is your anti-clockwise moment 2. So we want to find the distance always from the pivot. So we know that this whole length is 4 meters because you're uniform, so the weight is always at the center. So this distance, if I want to find here, this distance will be this distance here, or this one is what this is whole thing is for. So this is 4 minus 1.2, which is 2.8 meters. So here it's 4 meters. And the next question here, this one we will know that okay, the whole thing is 8. This whole length is 8. So if this whole length is 8, this is 1.2. So definitely this is 6.8 meters. So if we do the calculation now, we can straightforward say that okay, I have few moments, which is calculate the weight. We will say anti-clockwise moment 1 plus anti-clockwise moment 2 is equal to clockwise moment. So we already know the clockwise moment is equal to 180,000. What we got from here, this one, this goes down here, And then we have something like this. I'll just use this one. And what is anti-clockwise moment 1? So remember, it doesn't have to be 1. We are just using it for our benefit. This is 2.8 distance. This distance is 2.8 times 118 kilowatts. So 18 kilonewton, 18 times 1000 to remove the kilo thing, and then 2.8 plus we have anti-clockwise 2 as well. This goes here, and what is that? That is, let's say we have this force F times 6.8. F times 6.8. So if you do the calculation, it should be very easy. Your F is equal to 19000 Newton. 19000 Newton. And you get 3 marks for this straight away. If you get something like, remember we just rounded up, the actual answer was 19058.8. We rounded that to this. So if they don't tell you that write your answer in this, you can do some roundup. That's fine. But you have to be very careful that you don't make mistakes in rounding up. Next question from the same year is number 9. So this question is about momentum. So for momentum, we have already seen few questions. Here the first question asks you simply that moment is equals to mass time velocities. I have noted down some important things, that this toy train here has a mass of 0.39, this is given, and this has a velocity of 0.56. That means this one moves with a velocity of 0.56 meter per second, and this truck here is now at speed of 0 because it's not moving, it's released. Okay, now calculate the moment of the toy train. Remember, it's only 1 mark, that means it has to be very simple. So I can just say that moment is equals to mass into velocity. I just mentioned the above line. So you can say, okay, moment is equals to 0.039 times 0.56, and this should be equal to 0.022 kg meter per second is the right unit. So we will move quickly to the next question here. This was very easy. The next one here, it says calculate the mass. So let me just quickly tell you what happens. So here this short train moves down here and hits this one. Now they are joined together, move together with a velocity of 0.56. Now what they're moving is, both of them are moving with a velocity of 0.26 meter per second. Now if we look down, we know that okay, moment before the collision was 0.022, and then we know that we don't know the mass of this two now, so let's assume we'll say that okay, this both mass is m, so mass of this times 0.26. If I do the calculation, 0.022 divided by 0.26, this will give me a value of 0.084. But understand that this is the mass of this and this combined. But we already know the mass of this one. It was given on this part here, that it has a mass of 0.039. So this has a mass of 0.039. So if I do the calculation, mass of train, mass of truck, this should be equal to 0.084 is the combined. If I take away the previous one, I will get 0.4045. This is the mass of this truck, and it's in kg, so we are good to go. Again, if you look at the numbering, I'll just quickly explain you, this will help you. So here for conservation, using the concept of conservation, we got 1 marks here. Okay, this gave you 1 marks here. You got 1 marks for this. You got 1 marks for this. 1 marks for this calculation. So finally, just to find the mass, you got another 1 marks. So in the exam, when you find that this question is about 3, you can understand that, okay, there has to be some calculations that you need to do. If it's a straightforward like this one, just multiplying, and you know the momentum before as well, there will mostly be 1 or 2 marks. Okay, this is one important thing. Marks will give you an indication how much work you have to do. Now, if I come to number B, it says that this information is important to read. It says the two trucks are identical, so their velocity will be same as when they are just one truck. So now when they are doing the experiment, what they have done is they have introduced a new truck. Because the new truck is saying, he's saying that, okay, previously it was moving with a velocity of 0.26. Now with the incursion of this new truck, you will have the same velocity. Again, that means you will have the same velocity. But if you look at the momentum formula, what does the momentum say? Momentum is equals to mass times velocity. So what have you done? You have multiplied the mass because you have taken identical mass. That means your mass has increased. If your mass has increased and momentum hasn't changed because you're still dropping the vehicle at the same way. So here it says that the vehicle is being dropped in the same way as before. That means this momentum here hasn't changed. So if this hasn't changed, of course your velocity will change. Otherwise, how are you going to maintain the conservation of momentum? So for this reason, what we can say here is, but here they are asking you discuss whether the student's conclusion is correct or not. So you just have to say if it's correct or not. So the way we will do it is we will use the explanation from the scratch. So the first thing we will say that the total mass is now greater. Then we'll say that, okay, total momentum is the same as before, because I just mentioned that this was same. We didn't change. It says here the same way. That means your mass haven't changed, your velocity haven't changed. So the total momentum is the same as before. And so the third one, we will definitely say, so the velocity will go down just because you have to balance it. So we will say that velocity will be lower than before. So there was 3 marks. You have mentioned everything and you should be good to go this one. So this is the last question. I think we have done enough from paper 2, and this will be good enough to make you understand how the marking criteria works and how you can obtain most marks in here. So this is end of this video. We'll move to the next one now.